We'll start with objective 1, standard form. So you're used to seeing quadratic functions that look like this. F of x equals ax squared plus bx plus c. That's a quadratic function. This is in what our book calls general form. That's the general form of a quadratic function. Interestingly enough, the textbook you guys used last year in Algebra 2 called this standard form. and most other textbooks do as well, but our book calls this general form. So we'll stick with that, general form. Okay. Standard form, or what our textbook calls standard form, looks like this. A times x minus h squared plus k. This is what's referred to as standard form. It's more commonly known in other textbooks, I think I heard somebody say it, as vertex form. I will be referring to it as standard form just because that's how our textbook refers to it. And on the test as well, I'm going to say write it in standard form, but just so you can make some transformations in your mind. Standard form is really what? Vertex form. If you want to think vertex form, that's fine. Okay? And the reason it's called vertex form in most applications is because the vertex is part of the equation. The vertex is h comma k. And you find the vertex using the same method that we did on the last test. Inside the function represents a horizontal movement left to right. Outside the function represents a vertical transformation up and down. What we're going to be doing is taking an equation that's in general form and rewriting it into standard form. So put this down. To write the quadratic function in standard form, you're going to love this. Use complete, what's the phrase? Complete. Anybody remember this last year? Complete the square. Do you remember this fondly? Complete the square method. It's just kind of an algorithm. It has a bunch of steps. If you do the steps in the same order every time, it's just something that you can memorize and get used to doing. It's not that it's easy to do, but it's not a very high level of thinking problem either. It's just, okay, you do this first, you do that second, you do this. It's just something that you memorize doing. It's not too difficult of a problem. Let's do example 1. Write the equation in standard form. Part A. The function is f of x equals x squared minus 8x plus 1. Just curious, does anybody happen to remember the process of completing the square? If you don't do it all the time, it's one of those things that's easy to forget, but what do you think? What do you mean ax?
Like put x squared minus 8x to parentheses.
Oh, right here?
Yeah.
Okay. Keep going.
The negative 8, you divide it in half and then square it.
Keep going, yeah.
And then you add that number on the end and then the factor to be the square.
Good. I think you pretty much got that. Now, depending on who you've learned this from, there are subtle differences in how it's presented. I like to do it a certain way. Other instructors might do it a little bit differently. So I'll show you the way that works best for me, and for just what I've seen for most students. You always start by subtracting the constant or adding the constant. Whatever it is, move the constant to the other side of the equation. Just get rid of it for the time being on the right side. So we're going to have f of x minus 1 is equal to x squared minus 8x. The reason we're getting rid of that constant, if we were to look at the original equation, x squared minus 8x plus 1, does this factor? Is there anything that multiplies to 1 that adds to negative 8? It doesn't factor. So what we do is we get rid of that constant, and we put a new one in its place. We have to replace that constant with a new number. It's not just any random number. Okay? The number that fills in that spot is half of b raised to the second power. Half of b squared. This is b right here. That's your b value. So if you take half of that, you get negative 4. Negative 4 squared is positive 16. So we're going to add 16 to that blank spot. This is an equation now. If you do something to one side of the equation, you've unbalanced it. You got to do it to the other side to balance it back out. So you're going to add 16 to keep the equation balanced. Now on the left side, you have f of x plus 15. And here on the right side, we have x squared minus 8x plus 16. What was the point of putting that 16 in there? It will factor, and it won't just factor. It factors in a very peculiar way. What multiplies to 16 that adds to negative 8? Negative 4 and negative 4. The point is it has two identical factors. It factors into x minus 4 times x minus 4. And that's important that it factors into two identical factors, because something multiplied by itself, is there another way of writing this? Squared. Yeah, that's why it's important to have two identical factors. You can have x minus 4 squared rather than x minus 4 times x minus 4. And we started with f of x isolated, so we need to end with f of x isolated. So I'm going to subtract the 15 back over to the other side. And now we have f of x is equal to x minus 4 squared minus 15. Okay. What's this form called right here that we finished in? This is standard form. What did we start in? We started in an equation in general form right here. How did we go from general form to standard form? What's this process called? Complete the square. And the reason I'm having you make this connection, I'm not going to provide those directions. I'm just going to say on the test, write the equation in standard form. It's up to you to know how to do that. If it says write it in standard form, what's the process? Complete the square. Complete the square. What's the point, by the way? Why is standard form considered better maybe than general form? Why not leave it in general form? Which one would you rather graph in? Would you rather graph something in general form or graph it in standard form? Why standard form? It's much easier to find the vertex, and it's also much easier to talk about minimum and maximum value. So there is a point to this, completing the square. Makes it easier to find the vertex for graphing purposes. Also, this is kind of a lesser known, I guess, advantage of completing the square, or being good at completing the square. If I ask you to solve this equation, if I set that equal to 0 and ask you to solve that, how would you solve that? How would you have solved that last year, maybe, in Algebra 2? Does it factor? No, you cannot solve it by factoring. Can you use square roots on both sides? You can't use square roots on both sides. So how are you going to solve it? Remember that quadratic formula? That was kind of a beast, wasn't it? Well, consider this, you guys. This is not very often taught, but it is kind of a nice way to not have to do the quadratic formula. Aren't these the same equation right here? This one in general form and this one in standard form? If you complete the square and write it in standard form and then set it equal to 0, can you solve that equation without using the quadratic form? The answer is yes. Check this out. If you added 15, now you have x minus 4 squared. How do you get rid of an exponent of 2? Square root both sides. So now you have x minus 4 is equal to plus or minus square root of 15. Now what can you do to isolate x? Add 4, Now you have plus or minus square root of 15 plus 4 is equal to x. You get the same solution that way as if you had used the quadratic formula. Okay, so you can use completing the square method to also solve equations if you're not particularly fond of the quadratic formula. Most students aren't. Let's have you guys try one of these, not solving the equation, but writing it in standard form. Let's do part B. Do this one on your own. Y equals x squared plus 12x minus 9. Write that one in standard form. Hey!